Alright, welcome to Algebra class. Today, Monday's class is a 2-hour video, and tomorrow, Tuesday's class is also going to be a 2-hour video, and tomorrow's video should be up by around 3 p.m. tomorrow. Hopefully the YouTube format is okay for the first couple days. Of course, feel free to pause whenever you'd like. And I would recommend getting a notebook or just some paper to write with, because you'll definitely want to be writing things down during this class. Okay, so starting Wednesday, we're going to meet at Gear Library at 2:30 p.m. and it'll last until 4:30 p.m. and it will be every weekday, Monday through Friday, except of course today and tomorrow, and it will last 3 total weeks. Now, this may or may not be cut off on the screen. I'm not sure how it will look on YouTube, but it should say that the materials you're going to need for this class, you should definitely bring something to write with and a notebook probably. Any kind of paper really will do. So you're going to definitely want to write things down. And also, I would highly recommend bringing a folder because there will be a lot of handouts during this course. A lot of packets that just contain some useful information for you to just kind of review on the evenings of this course to get ready for the next day. So yeah, a folder will be very useful for you. Paper, something to write with, and that's pretty much it. You won't need a calculator, but if you bring one, that's totally fine. We're actually going to try to do most of the calculations by hand, and there won't be any obnoxious calculations, but it will be instructive to work out some of the computational things by hand for this class. So that's why I'm not requiring a calculator. This course is not going to be graded, but I will give you a little bit of some daily homework, usually like a few problems just to try and work on your own. They may range in difficulty, and it's totally okay if you can't solve them, but definitely at least try your very best. And then, of course, the next day in class, we'll go over how to solve them, and we'll see if anyone had any differing methods. And so yeah, so we'll have a little bit of homework every night. Okay, so this course in algebra has 2 particular emphases. So one emphasis will be making sure we cover all topics that you may see in an algebra class. So we'll touch on all of those topics that you probably will see or have seen in an algebra class. And the second emphasis will be on problem solving. So we will solve a lot of problems in this course. Many of them will be pretty hard. So my hope is that we'll take the regular algebra content and we'll make sure we practice it, and we'll make sure we have lots of opportunities to solve interesting problems. Alright, I'd also like to let you know that on this YouTube channel, there is a logic class. The first couple videos are going to be posted. If you are interested at all, you should definitely check them out. And I know you might not be available from 12 to 2, but if you are available and you're interested, feel free to join in to the logic class on Wednesday. After having watched the first couple of videos, that'd be totally fine. It's the same price as the algebra class. Yeah, just thought I'd throw that out there in case you're interested. So let's start to talk about algebra. So in algebra, we make a heavy use of variables. Now, a variable often will be just some number that we don't know what it is yet, but we have to solve for it, like solving for x. And other times, specifically on the next slide, we're going to use the variables x and y to represent any number at all. And so algebra can be very useful to show relationships and patterns between numbers that can be hard to categorize if we're not using that level of abstraction. So basically, what that's going to mean, we can just start by looking at this example here. So we're going to look at a very nice example of how algebra can be useful, and to kind of show you what algebra is and what it does. Let's start by trying to solve 102 squared minus 98 squared. And if you aren't familiar with this notation, the little caret, the little capital A without the horizontal line, that's kind of raised up between the 102 and the square, that's kind of, you might see that on a calculator. It's just because the software I was using doesn't have the ability to represent exponents very well. But especially on this video and tomorrow's video, make sure you're aware that that just means squared, or raised to that certain power. So we have to evaluate 102 squared minus 98 squared. Now obviously this is very doable if we just square 102 by hand, and then square 98 by hand, and then subtract, getting 800. That's a perfectly fine way to solve this, but it's definitely not the best way to solve this problem. There's a much easier way, and this is where algebra comes in. So if x and y are any numbers, okay, we're just going to let the variables x and y represent any number at all. Tell me, what do we get when we take the quantity x minus y times the quantity x plus y? So if you're familiar with the distributive property, or if you're familiar with FOIL, or if you're familiar with generic rectangles, you can definitely try to multiply that out and see what you get. I always think of it just as the distributive property. So that x minus y, the first term, you're going to take the x and you're going to multiply it by each term on the second set of parentheses. So you'll take x times x plus x times y, and then you'll move on to the minus y, and you'll do minus y times x plus minus y times y. And that comes out to x squared plus xy minus yx minus y squared. Now make sure you understand how we got that. Okay, now xy is the same as yx, and that's because multiplication of numbers is commutative, right? The commutative property. So plus xy and minus yx will cancel out, giving 0. So this means we just have x squared minus y squared. And this is one of the first facts that you need to understand in algebra, okay? So whenever you have x squared minus y squared, that expression, that algebraic expression there, x squared minus y squared, you can always replace it with x minus y times x plus y, right? They're the exact same, they mean the same thing, they're just represented differently, right? They're just different representations of the same exact thing, right? X squared minus y squared is equal to x minus y times x plus y. And whenever you see x minus y times x plus y, you can change it to x squared minus y squared, right? Just by multiplying it out. So this is true for any value of x and y, right? X and y can be anything at all. They can be any numbers at all in particular, right? So in this problem, when we have 102 squared minus 98 squared, if we just think of x as equaling 102, and if we think of y as equaling 98, well, this problem, it is x squared minus y squared, right? It's something squared minus something else squared. So what is something squared minus something else squared? Well, we subtract them and then we multiply it by what we get when we add them. So we get 102 minus 98 times 102 plus 98. And in this problem, it's super nice because 102 plus 98 is 200, and 102 minus 98 is 4. So this is actually a super easy problem. As long as you recognize what you need to do, as long as you recognize the algebraic trick, then this problem becomes super easy. Okay, and this particular algebraic trick has a special name. It's called difference of squares. So I used a and b as the variables here. It doesn't matter what variables you use. It's true for any two numbers, right? Anything. So you definitely need to memorize this for sure. It's true for any numbers we plug in for a and b. It's always true. So you should always be on the lookout for opportunities to use this fact. So if you see something that has the form of one side of the equation here, right? If you see something like, oh, maybe x squared minus 9, x squared minus 9, well, 9 is 3 squared. So that is of the form of something squared minus something else squared. So we can always factor it as, well, if it's x squared minus 9, we can factor it as x minus 3 times x plus 3, right? You just have to figure out what a is and what b is. Okay, so if you ever have trouble with recognizing a difference of squares, just think, are we taking a square minus another square? And if we are, then it's possible to factor it. Okay, so here is a practice problem here. And the problem I want you to work on for a few minutes here, what is the largest prime factor of 2 to the 16th power minus 1? Now, obviously, I'm not wanting you to compute 2 to the 16th power and then subtract 1 from it and then try to figure out how to factorize that number, right? That's not the approach you should take to this problem. What I want you to do is to recognize 2 to the 16th minus 1 as a difference of squares, okay? So 2 to the 16th power, obviously, it's 2 being raised to the 16th power, but I claim that that number, it's something else squared, okay? And I want you to figure out what is a in this problem and what is b in this problem. And once you figure out what a is and what b is, then you can write it as a minus b times a plus b, okay? And that'll help you factor it. And then at that point, you will have to factor something further, right? You'll notice that there's still a difference of squares in there, and you'll have to factor it further. Okay? And once you factorize this as much as you can, then you're going to figure out, okay, in the parentheses, what number is this actually? Okay? And then you're going to see, oh, well, 2 to the 16th minus 1, that's just this number times this number times this number times this number. And from that, try to figure out what's the largest prime factor in there. Okay? So I'll give you maybe 6 minutes to work on this because you'll have to factor it and then you'll have to factor it completely and then you'll have to figure out what's the largest prime factor. Okay, good luck. Alright, so hopefully you got a chance to work on that. If you didn't figure it out, that's okay, because we're just about to talk about it. Okay, so the solution here, so this is the difference of squares, right? A is equal to 2 to the 8th power, right? If we have 2 to the 8th power and we square that, that's going to give us 2 to the 8th power, and then we'll have to double the exponent, so 2 to the 16th. So it is a square. And then 1 is also a square, right? Like 1 squared is equal to 1, so b is just equal to 1. So a is equal to 2 to the 8th, and b is equal to 1. So that factors as 2 to the 8th power minus 1 times 2 to the 8th power plus 1. Now it's interesting to note that 2 to the 8th power minus 1, that is actually a difference of squares as well, right? That's 2 to the 4th power minus 1 times 2 to the 4th power plus 1. And then again, 2 to the 4th power minus 1 is a difference of squares, and so on. But if you know what 2 to the 8th power is, you could stop right here and just notice that 2 to the 8th power is 256, and so this 2 to the 16th power minus 1 is actually equal to 255 times 257. Okay, so 255, obviously that's not prime because it's divisible by 5. But 257 is now our candidate for, that's potentially the largest prime that divides 2 to the 16 minus 1. So we have to check if 257 is prime. Now this isn't really an algebra thing, but this is really, really good to know. So if you want to check that a number is prime, you only need to check each prime number less than the square root and check if those prime numbers are factors of 257. And once we get to that point, we can stop. So we check 2, obviously it's not even. We check 3. Now if you know the trick for divisibility by 3, we add 2 plus 5 plus 7, and that's equal to 14, and 14 is not divisible by 3, so 257 is not divisible by 3. Right? So the trick for 3, you add up the digits and see if that's divisible by 3. If you don't know the trick, that's fine. You can just divide it by 3 and see if it goes in evenly. Okay, next 5. Well, 5 doesn't go in because it doesn't end in 5 or 0. 7, now there is a trick for 7, but most of the time it's probably easier just to divide it. So divide by 7 and we see it doesn't go in. We can check 11. There is a trick for 11 as well, but we can also just divide it through and it doesn't go in. And also 13 doesn't go in either. Okay, and that proves that 257 is prime, right? Because 2, 3, 5, 7, 11, and 13, because none of those numbers go into 257, we know for certain that it's prime. And that's because any composite number is made up of primes, so this is the 6 smallest primes, so we don't need to check if, say, 14 goes into it, because we already checked 2 and 7. We don't need to check 6, because we already checked 2 and 3, and so on. And we can stop at 13 because the next biggest prime, 17, well, 17 squared is 289, which is bigger than 257, right? So the square root of 257 is kind of like the curtain where we can stop checking prime numbers once we get to that point, okay? So 17 is too big. We don't care if 17 goes in or not. Well, actually, we know that 17 doesn't go in because we've checked the primes less than the square root. Okay, so 257 is prime, so that is the answer, 257. So, so this problem is much, much harder if you don't realize that you can factor, okay? The very first trick we just learned, difference of squares, super, super, super important. You should always look for difference of squares to help you in a certain problem. Okay, now it's important to realize that of course we can factor numbers, right? If we have two squares like 64 minus 16, obviously that's 8 squared minus 4 squared. we can factor that as 8 minus 4 times 8 plus 4. And of course, in this case, the numbers are so small that you probably wouldn't bother factoring it anyway. But we need to make sure we can factor completely algebraic expressions. So here is an application of difference of squares that's super important. We're going to factor these algebraic expressions. So we're going to factor x to the fourth minus y to the fourth. Now, if you remember, your a squared minus b squared is a minus b times a plus b. You can let a be x squared, and you can let b be y squared. And of course, this factors as x squared minus y squared times x squared plus y squared. But we're not done quite yet because the problem does say factor completely, and we notice that when we factored x to the fourth minus y to the fourth, we got x squared minus y squared times x squared plus y squared, but there's still a difference of squares there, so we factor that, and we get x minus y times x plus y, and still times x squared plus y squared. So at this point, it is fully factored. And x squared plus y squared, that does not factor. So if you ever see a sum of squares, that doesn't factor. Okay, that's what we call irreducible. Only difference of squares has this nice special factorization. So if you ever see a sum of squares, you can't really do much with it as far as factoring is concerned. Okay, so at this point, try this problem. You're going to factor completely 4x squared minus 9y squared. And of course, the key is going to be you're going to recognize it as a difference of squares. Okay, hopefully you've had enough time to figure out how that factors. It is 2x minus 3y times 2x plus 3y. And of course, if we square 2x, we get 4x squared, which is what we had. And if we square 3y, we get 9y squared. So that was, in fact, a difference of squares. Okay, so let's move on to the second key algebra fact, squaring a binomial expression. So binomial just means that there's two terms in there. So as you can see in the parentheses, there's an x and there's a y. And because there's two terms, x plus y, that's called a binomial. And when we square it, you need to always make sure that you don't make one of the most common algebra mistakes out there. And that common algebra mistake is that when you're taking x plus y and you're squaring it, never just assume it's x squared plus y squared. It's not x squared plus y squared, because if you were to use the distributive property and do x plus y times x plus y, you'd get x squared plus xy plus yx plus y squared, which is not the same thing as x squared plus y squared. So you need to remember this. Definitely remember this. And if you want to see this in a different way, you can do generic rectangles, put an x and then a y, and then an x and then a y on the other side of the rectangle, and then multiply it out and then add up the terms. That might be something you're familiar with. But yeah, this is a really important fact. Now, I want you to try to use this fact to solve this next problem. We have a right triangle, and remember a right triangle is one with a 90-degree angle, with legs of length x and y. So one of the legs has length x, and the other leg has length y. So you'll definitely want to draw this right triangle and label the sides as x and y. and it says it has an area of 18 and a hypotenuse of length 10. So right away you can label the hypotenuse as having a length of 10. And the question is, what is the perimeter of the triangle? So you need to find the distance around the triangle. And you have to use the fact that the hypotenuse is length 10, and you'll have to use the fact that the area is 18. And I just want to give you a little hint. You don't need to know the exact value of x and y to find the perimeter, right? You don't need to know what x is, and you don't need to know what y is. You only really need to know what x plus y is. So if you figure out what x plus y is, that's great, right? You don't need to figure out what x is specifically and what y is specifically. You only need x plus y to figure out the perimeter, right? And then of course you'll add 10 to it. So that's my hint. And also don't forget to use the Pythagorean theorem. If you're not familiar with the Pythagorean theorem, it's that if there's a right triangle, and the legs are length x and y, and the hypotenuse is length z, then x squared plus y squared equals z squared. That's the Pythagorean theorem. You're going to have to use it for this problem. And you'll also have to use the squaring a binomial expression. You'll have to use that fact. So try your hand at this problem. I'll give you a little bit more time to solve this problem. And then, yeah, on the next slide, we'll show you how to do it. Okay, hopefully you've had enough time to solve the problem. If you didn't figure it out, that's totally okay. The most important thing then for you is to just look closely at this solution so you know how to do it. Okay, so the right triangle has sides of length x, y, and hypotenuse 10. By the Pythagorean theorem, we have x squared plus y squared equals 100. And the area of the triangle is 18. And of course, the way to figure out the area of a right triangle is base times height over 2. So we just have x times y over 2. So from the area information, we already know that x times y is equal to 36. And that's definitely going to come in handy. So notice at this point we have two facts. We have two algebraic equations that we can use. We have x squared plus y squared is 100, and we have x times y equals 36. So if you do the hint that I told you about, squaring the binomial, squaring x plus y, we get x squared plus 2xy plus y squared. Now this is super useful because x plus y is what we were looking for, right? We didn't care about exactly what x was or exactly what y was. We wanted to know what x plus y was. So notice that we can substitute values into this equation, right? We can square root both sides, first of all, and just get x plus y is the square root of the right-hand side. And notice that since x squared plus y squared is 100, we can plug in 100 onto the right side. We can replace x squared and y squared with 100. And notice also we have 2xy sitting there, and since xy is 36, 2xy is 72. So the right-hand side of that equation is 172. So if we square root both sides, then we just get that x plus y is equal to the square root of 172. And therefore, since the perimeter is just the distance around, it's x plus y plus the hypotenuse, so the perimeter is 10 plus the square root of 172. And of course, you can reduce the radical if you know how to do that, and if you'd like. If you reduce the radical, then we get, let's see, I believe it's 10 plus 172, so that's 4 times 43, I think. Yeah, so you get 10 plus 2 root 43. Okay, and now try your hand at these next two problems. I want you to simplify these two expressions. So we have a minus b times the quantity a squared plus ab plus b squared. And then I also want you to simplify a plus b times the quantity a squared minus ab plus b squared. And these are going to simplify into some really important things that we'll talk about on the next slide. So, um, so just go ahead and simplify this in any way that you know how, and then we'll check it on the next slide. Okay, hopefully you've had enough time to simplify that. The answer for the first one is a cubed minus b cubed, and the answer for the second one is a cubed plus b cubed. Okay, so these are two more really key algebraic facts. You'll definitely want to memorize these. Now are uh, these are a little bit harder to memorize, but they're still not too bad. One way I like to use to memorize this is I know that for both factorizations, there's exactly one minus sign, and the other two signs are plus. And also for a cubed plus b cubed, the first factor is always a plus b, and for a cubed minus b cubed, the first factor is always a minus b. So again, these algebraic facts are super important, and this works no matter what number a is and no matter what number b is. So if you ever see a difference of cubes or a sum of cubes, you can always factor it in this way. So here's a problem for you to try. I want you to factor x to the 12th power minus y to the 12th power and factor it completely. So if you factor it once into something times something else, then I want you to make sure that each of those factors, I want you to make sure that those are factored completely. So make sure that you recognize, well, x to the 12th minus y to the 12th, this is a difference of squares, and it's also a difference of cubes. So you can start out factoring it either way that you want, and both will get you to the correct answer. So go ahead and try this, and we can check your work on the next slide. Okay, hopefully you've had enough time to work on this problem. The method I'm going to present to you is recognizing it as a difference of squares. If you started out by breaking it up as a difference of cubes, that's also perfectly fine. But since I did it as a difference of squares, I got x to the sixth minus y to the sixth times x to the sixth plus y to the sixth. And then notice x to the sixth minus y to the sixth, that's a difference of cubes, and it's also a difference of squares. So you can factor it either way. I chose to do it as a difference of squares. So you get x cubed minus y cubed times x cubed plus y cubed. So notice x cubed minus y cubed times x cubed plus y cubed, that all was how x to the sixth minus y to the sixth factored as a difference of squares. And now we're going to take x to the sixth plus y to the sixth, and we're going to factor that as a sum of cubes. Okay? So if we factor it as a sum of cubes, well, x to the sixth power, what is that the cube of? Well, it's the cube of x squared. So if we take x squared and we cube that, we get x to the sixth. And likewise, if we take y squared and we cube it, we get y to the sixth power. So that's what A and B are going to be. If you want to look at like how a sum of if you want to go look at how a sum of cubes factors on the last slide, then you can see kind of what A is and what B is, and then you'll see that the second factor here. Oh, I actually made a typo there. It should be x to the fourth minus x squared y squared plus y to the fourth. So sorry about that. So the solution, the fully factored form, is x cubed minus y cubed times x cubed plus y cubed times x squared plus y squared times x to the fourth minus x squared y squared plus y to the fourth. Okay, now I have a problem for you. This one is, if the sum of two numbers is 1 and their product is 1, then what is the sum of their cubes? So in this problem, you're going to want to have two variables, x and y maybe, and you're going to say, okay, well, we know that x plus y equals 1. We also know that x times y is equal to 1. And the problem is asking for x cubed plus y cubed. So already you should be noticing that the problem is asking you to find x cubed plus y cubed, and we know that that factors. So that's a sum of cubes, so that factors in a certain way, and you'll definitely want to use that fact to figure out how to solve this problem. So I'll give you some time to work on this problem, and then we'll go over it on the next slide as well. Okay, hopefully you had a chance to try that problem. If you didn't quite get it, that's perfectly okay. Then what I want you to do now is just look closely at the solution so you can see how to solve it. Okay, so x cubed plus y cubed. My hint to you was that it factored, and it does. X plus y times x squared minus xy plus y squared. And then, because we know that x plus y is equal to 1, we can just substitute that into the x plus y we see in our factorization. Okay, and also, since xy equals 1, we can just substitute that in. So hopefully you see in this problem that, well, when we factored x cubed plus y cubed, x plus y we could just replace with 1. And xy we can just replace with 1. Now all that's left is x squared plus y squared. Now how are we going to figure out what x squared plus y squared is? Well, there's a little trick. We can take x plus y and square it, right? We're just getting this algebraic identity here. X plus y squared is x squared plus 2xy plus y squared. So since we know that x plus y is 1, 1 squared is 1, so we have 1 equal to x squared plus 2 plus y squared. And that's because xy was equal to 1, so 2xy is equal to 2. So then at this point we know that x squared plus y squared is equal to negative 1. So finally, x cubed plus y cubed is just going to equal 1 times negative 2, which that's just negative 2. So yeah, hopefully you found out the usefulness of squaring binomials and factoring sums of cubes. All of that put together got us the answer to this problem. Okay, this one is slightly harder, but I want you to try this next problem. If x plus y is equal to 4 and x times y is equal to 2, figure out what x to the 6th power plus y to the 6th power should be. Alright, hopefully you had enough time to try that problem. So here is a solution. So we're given that x plus y is equal to 4 and xy is equal to 2. Now x to the 6th plus y to the 6th, that is a sum of cubes. So that factors as x squared plus y squared, right? Because x squared cubed is x to the 6th and y squared cubed is y to the 6th. It factors as x squared plus y squared times x to the 4th minus x squared y squared plus y to the 4th. Now already we could substitute in, because that one term minus x squared y squared, that's just minus 4, right? Because xy is 2, and if you square both sides of xy equals 2, you get x squared y squared equals 4. So we could substitute that in, but actually first, let's square the binomial x plus y. This is going to help us a lot because it's going to help us figure out what x squared plus y squared is, right? Because we're given that x plus y is 4 and xy equals 2, that algebraic fact there, the x plus y squared is x squared plus 2xy plus y squared. The 2xy and the x plus y squared, those pieces are already given to us by the problem, and the x squared plus y squared is what's left. So from that equation, we get that 16 equals x squared plus y squared plus 4, right? Because xy is 2, so 2xy is 4. So then, just subtracting 4 on both sides, x squared plus y squared is 12. And also, based off our discussion about a minute ago, x squared times y squared is equal to 4. So, next, we're actually going to try something that maybe you thought of, maybe you didn't, and it's totally okay if you didn't think of this. If we take x squared plus y squared and we square that, we're going to get x to the 4th plus 2x squared y squared plus y to the 4th. So from that, because we already know that x squared plus y squared was 12, we're going to get 144 equals x to the 4th plus y to the 4th plus 8, because that middle term 2x squared y squared is equal to 8. And then finally, x to the 6th plus y to the 6th, which is what we wanted all along, because that top equation tells us that it's x squared plus y squared times x to the 4th minus x squared y squared plus y to the 4th. We already know now that x squared plus y squared is 12, and we know that x to the 4th plus y to the 4th is 136, and we know that minus x squared y squared gives us a minus 4. So our answer is just 12 times 132, which isn't too hard to compute, 1,584. So congratulations if you solved that correctly, that's good. And if you didn't, that's okay, because there's actually an alternate way to solve this, and I want you to try and see if you can do it this way. And it's always instructive to be able to solve a problem two different ways. So the first relation that they give us is x plus y is equal to 4. I want you to cube this relation and then square the relation. So cube then square the relation. And what I mean by that is cube both sides and then make any substitutions that you are able to make, and then square both sides. And recall, if you don't remember how to do this, x plus y cubed. Again, this is not x cubed plus y cubed. This is something entirely different. This is the quantity x plus y. That whole thing is being cubed. So you can do that by taking x plus y times x plus y times x plus y. If you know how to calculate that, then go for it. If you don't know how to do that, you can really think of that x plus y times x plus y times x plus y. You can think of it as multiplying two binomials together. If you just put parentheses around the first two sets of parentheses, you can just multiply out x plus y times x plus y, and then you can figure out what that is, and then multiply it by x plus y again. So go ahead and try to solve this by cubing, then squaring the relation x plus y is equal to 4. Okay, so the same problem but done a different way. If we cube both sides, then we're going to get x cubed plus 3x squared y plus 3xy squared plus y cubed is equal to 64. And then since xy is equal to 2, if you notice the one term 3x squared times y, there is an x times y in there, right? So we have 3 times x times y. And so we have 3x times 2, so that's 6x. And then similarly, for the 3xy squared, if we substitute in the x times y equaling 2, there's only a single y left after that, so we get 6y. So make sure you understand why that is. And then at this point, we now have that x cubed plus 6x plus 6y plus y cubed is equal to 64. However, we do have that fact that x plus y is equal to 4. We can still use that. And notice 6x plus 6y, if we factor out a 6 from that, then we get 6 times x plus y, right? Kind of like the reverse distributive property. That gives us a value of 24 for the 6x plus 6y. And that's because x plus y is 4, and we're multiplying it by 6, so we get 24. So we can subtract 24 from both sides, and then we just get x cubed plus y cubed is equal to 40. So that's super useful. We now know what x cubed plus y cubed is equal to. Now, if you're looking at that, you could say, hey, wait a minute. X cubed plus y cubed factors. We know how to factor a sum of cubes. However, I mean, you could do that, but it's not going to help you too much, because if you did that, you get x plus y times x squared minus xy plus y squared equals 40, and x plus y is 4, so you'd get x squared minus xy plus y squared is equal to 10, but we don't really need to know what x squared plus y squared is in this approach. So instead of doing that, instead of factoring that, we're going to square it, because really, remember, the goal all along was to figure out what x to the 6th power plus y to the 6th power was. So if we square x cubed plus y cubed, we're going to get x to the 6th plus 2x cubed y cubed plus y to the 6th. And obviously, if we square 40, we're going to get 1600. Okay, but now we do know what x times y is. That's equal to 2. So that middle term, 2x cubed y cubed, that's actually, we just take xy and we cube it, and then we multiply by 2. So since xy is equal to 2, that's going to be equal to, if we cube it, we get 8, and then if we double that, we get 16. So if we subtract 16 from both sides, we end up with x to the 6th power plus y to the 6th power equals 1,584, which is the same exact value we got when we did the problem the other way on the last slide. Alright, so that was a lot of algebra today. Hopefully you got a lot of practice doing things to become more familiar with these algebraic facts. We covered 4 algebraic facts today. We covered the difference of squares, we covered the sum of cubes, the difference of cubes, and then we also covered squaring a binomial. Now, we technically also cubed a binomial at one point, as in like the top of this slide right here. We cubed a binomial. That could be an algebraic fact number 5. Just, do you know how to cube a binomial? And so all of these things, if you're seeing a lot of this for the first time, that's totally okay. Just try to study this video, try to practice with these things. And you can definitely email me if you'd like, or you can wait and ask questions on Wednesday. Tomorrow's video is going to be a lot of problem solving as well. We'll cover a few more topics, and yeah. Now, since today and tomorrow are YouTube videos, they're a little bit more problem solving heavy. So on Wednesday, Thursday, and Friday, there will be more of things that you'll see in your algebra class and expanding on that. But these first couple days, I just wanted to make sure that We get some really common and useful algebraic identities out of the way so that you have these to use in problems in the future. You definitely want to memorize these algebraic facts and be able to recognize when you can use them in a problem. Okay, so here are a few homework problems for tomorrow. Try your best to work these problems today or tonight. You could also work on them tomorrow as well because we won't be meeting until Wednesday. The first problem here, find all possible values of AB given that a plus b equals 2 and a to the fourth plus b to the fourth is equal to 16. Now it says find all possible values of AB, and that's just because when you begin to solve this a little bit, at the end you'll see what it means. Okay, but the trick to this one, you're definitely going to want to square a binomial. You're going to want to know how to do that, and you're also going to have to rearrange that equation after you square it a little bit and then square it again. And maybe you can kind of see how to do it as you start doing the problem, but you'll square something twice, basically. For problem number 2, we have a cubed minus b cubed is equal to 24, and a minus b is equal to 2. And this says find all possible values of a plus b. And I started this problem because this might be harder than the other two, but I still definitely want you to try it. Now, obviously the first thing that jumps out at you is, well, a cubed minus b cubed, that's a difference of cubes. And a minus b is the first factor in the factorization of a difference of cubes. And obviously what's left is going to be a squared plus ab plus b squared. But actually, you're going to want to do something else. That might jump out at you, oh, it's a difference of cubes, so I can factor it. But actually, you're going to do kind of the opposite. And what I mean by that is you're going to take a minus b and you're going to cube a minus b. So you're going to have to figure out what that's going to look like and see if you can figure out what a plus b is off of that. So that's the hint for number 2. And finally, homework problem number 3 is find all prime factors of 3 to the 18th power minus 2 to the 18th power. Now this problem, obviously that's going to be a difference of squares. It also happens to be a difference of cubes. So you can choose either way to start out trying to factor this. And just know that you have to factor this all the way. And then once you've factored it enough so that you can see what the numbers actually are, you're going to find all the prime factors and you're just going to list them. All right? So that's homework problem number 3. Okay, now I'm actually going to give you one additional problem, and this is going to be the challenge problem. Now, the 3 problems on the homework might be hard enough already. If you don't have any clue how to do the challenge problem, that's fine, but I do want to give this as an option in case you finish the homework and you'd like an extra challenge. So I'm going to read the problem to you because it's very short. You're going to, and you might want to write this down on paper so you get this copied down. The problem is, find 2 4-digit numbers whose product is 4 to the 8th power plus 6 to the 8th power plus 9 to the 8th power. And I'll say the problem again. Find 2 4-digit numbers whose product is 4 to the 8th power plus 6 to the 8th power plus 9 to the 8th power. Alright, so the problem is asking, you're going to want to find 2 4-digit numbers such that when you multiply them together, it's going to equal 4 to the 8th plus 6 to the 8th plus 9 to the 8th. And this is a hard problem, but it's perfectly doable based off of what we talked about today. So good luck if you're going to go ahead and try that. Good luck on the homework problems, and yeah. I will see you tomorrow in the next video. It should be up by 3 p.m. tomorrow, Tuesday. And then we'll see each other on Wednesday. We'll all see each other when we come to class, and then we can finally start to talk about more topics.